Our last concept that we're going to take a look at is something called resonance structures. So formal charge is useful for deciding when resonance structures are appropriate. So let's draw the Lewis dot diagram for NO3 minus 1. We're going to put nitrogen in the middle, oxygen around the outside. Number of valence electrons, nitrogen is in group 5, oxygen is in group 6. 5 plus 3 times 6, and we're going to add an extra one because there's a -1 charge on the molecule. Gives us a total number of electrons of 24. If everybody has an octet, we need 32. Number of bonding electrons equals 8. 32 minus 24. That means that there are 4 bonds present. That means that if we need to connect 3 atoms and we need 4 bonds, that there are going to be a double bond present. Let's put those in. If there are valence electrons left over, well, we started with 24. We only used 8, so the answer is yes. There are some extra ones. In fact, there are 16 extra valence electrons. That means that we're going to have 8 lone pairs. And let's put them in as lone pairs around the oxygen. There we go. So we're all set. Now let's take a look at the formal charges. Well, if you look at those formal charges, you notice that the formal charge on nitrogen is +1, the doubly bonded oxygen is 0, and each one of the oxygen atoms is -1. You're like, oh, 3 atoms, formal charges, but if you add up all the charges, it sums up to -1. Okay, are we done? Not quite. What we need to think about is, all right, if we look at this structure, and we look at this structure, and we look at this structure, are these structures different? Who decides who gets the double bond? And the answer is they aren't. They are exactly the same. The reality is it's a better model to blend all the 3 structures. And the way we do that is we show our double-headed arrow. So one way to think about the structure is that the electrons are in resonance and are delocalized over more than 2 atoms. These resonance structures are present because the only difference is the arrangement of electrons. We haven't changed the way the atoms are connected. Those are the same. The only thing that we're changing is a double versus a single bond. So the skeletal structure is the same, and the difference is where we put the electrons. So the summary for our unit that we've just completed is you need to, 1, we know how to draw basic Lewis electron dot structures, and it helps to explain the chemical bond formation. The best Lewis structure will have the least number of atoms with non-zero formal charge. 3, resonance structures help to explain molecules with multiple atoms within the same molecule. And there are 3 exceptions to the octet breakdown. The next lecture we are going to do is we are going to do an introduction to VSEPR, valence shell electron pair repulsion theory. And we are going to look at molecules with lone pairs, without lone pairs, and we are going to use the shape to determine if there are dipoles. So that is our next class that we are going to take.